is Matthew Poes with Poes Acoustics, and in this video I'm going to talk about a recent site visit that I did for a project that was a little bit shocking to me. Probably shouldn't have been, but I just haven't had enough opportunities to get out to sites I think that were done by not the best integrators. I'm going to not tell the name of the integrator, but I will say it is not my friend Don Dunn's Haven Smart. In fact, they will be the ones fixing the problem. And so what I want to talk about is essentially what happens when you go to, you could do this yourself. So I would say this could be a DIY thing, or this could be going to an integrator or an installer. But one of the things that separates somebody like myself and a lot of these integrators in terms of the design side has to do with the understanding of acoustics. So when you have a fundamental understanding of the physics, basically, of how sound works in a room, it's easier to problem solve. So in another video that I did recently that we'll post probably around the same time as this one, I talked about like, what do you do in a non-ideal room? And I tried to make the point, we all deal with non-ideal rooms, and you could be a billionaire family with a massive mansion and you could still have a non-ideal room. It's really typical, and you just find ways to kind of engineer around it. Some of those engineering things can be expensive, and when you have the budget to do it, you use that to get better results. But other times, it's just being smart about how you use what you have. So in this particular case, the speakers that were spec'd were the wrong speakers for the size room. The room was huge. It was open architecture, which is very popular right now. It had very, very high ceilings, which is again very popular right now. And it was open to a lot of area. So this very large open area space, basically, I think I calculated it's very close, if not over 30,000 cubic feet. You're talking like 25-foot high ceilings. You're talking about probably, like, including the kitchen area, like 50 feet of length, 30 feet of width, including some other spaces that were there. Glass on 2 walls, floor to ceiling. I mean, it's just a lot of reflective surface, large volume. RT60 time was like 1.5 seconds or so, and that was with furniture and carpets and stuff. So not great. Not uncommon for a room of that volume, though. The speakers that were chosen, I'm going to make up. I actually don't know the exact model that was used, but this will kind of give you a sense. So there's a lot of products from companies that, like, the brand itself is okay. It's just that they sell like good stuff and cheap stuff. So Sonos, Speakercraft, these are companies that sell good stuff and cheap stuff. And you might argue that the cheap stuff is really good for the price, but the cheap stuff is still cheap. It has limited output. It's going to have a poorer frequency response. And those two things are really important to the problem that happened here. So what I refer to is like an architect grade or a builder grade speaker was chosen, or maybe it was like a step up from that, but it wasn't a good speaker, for the left and the right speakers and the surround speakers. The original design that the integrator came up with was just nothing more than a left and a right speaker and a left and a right surround speaker. No center channel, no subwoofer. Now, the TV was over the fireplace. It was, for the sake of argument, 65 inches, something like that. And the left and the right speaker was placed in the side walls facing each other about 15 feet up. So imagine you're sitting about 4 feet or less. Your ear height is going to be less than 4 feet, somewhere between 3 and 4 feet actually, in the couch. And 11 feet above your head is where the sound is coming from a left and a right speaker that are pointing at each other and reflecting off of each other's walls. Now, yes, side surrounds point at each other, but typically in line with your head. In a treated room, and in those scenarios, you don't hear the reflection all that strongly off the opposite wall. Also, it's a surround speaker, so those reflections are part of that ambience effect. The left and the right is supposed to be facing you, and it's supposed to have a certain aperture apart, about 30 degrees from center, 60 degrees total, to give you that sense of sound coming in front of you and being able to pan across the screen. So while they would be capable of being louder than what's built into the TV, the sound quality would be poor. Poor bandwidth, poor frequency response. The direct to reflected ratio would be very low, so there's a lot of reflected sound that's swamping what you're hearing. And so the signal to noise ratio of speech is very poor. Some will say, well, I thought that there was research that said reflections are good to improve speech intelligibility. They are if they fall inside the integration zone. They aren't when they fall outside of it. This room's so large that a lot of those reflections were happening, I measured these, they were happening way, way outside of that integration zone. So very strong reflections happening very late in time. So that's not actually good for speech intelligibility. The opposite is very poor for speech intelligibility. So the client was really unhappy with the sound. At some point along the way, they had complained to the original integrator who installed a center channel and a subwoofer. The center channel was a low profile design that was designed for rooms that probably would have been more like 2,000 cubic feet to 2,500 cubic feet at most. It really was for like a small to medium sized room. And it's a really good center channel for a small to medium sized room on a low budget. It was not appropriate for this room. The subwoofer that was chosen was actually a model that matched that. It has a 10-inch woofer, a couple hundred watts, that's it. Again, really good subwoofer for a small room, but it's just going to be lost in a room like that. And it was wired incorrectly in such a way that the subwoofer didn't work. So when we got there, the method they had used to connect it had essentially failed. But it was like, I call this robust, engineering robustness to the design. This was an approach that had a very high likelihood of failing, and so it shouldn't have been done in the first place. They should have built in a more robust solution to ensuring that all the equipment works. And that's because when people spend that kind of money for a system like that, they just want it to work. And so you as the integrator supporting it need to be in a position where you know it's likely to work. And then if it does fail, it's more like extraordinary circumstances than, well, that was probably going to happen. So in this case, the design was set up in such a way that the sound quality should have been expected to be bad. The robustness was low, and so it should have been expected to fail frequently, and it did. It was just a bad design. Like, I felt bad that this family had been sold this. So things that you guys should think about, I guess, or like lessons learned from this interesting bad install is that I think the integrator designed it this way because the room, there was so much glass, there was no place to put in a left and a right speaker. There were many open spaces that prevented speakers being placed at the correct height. Rather than thinking creatively about what should be the right solution to this, they did the, I'm going to call it low-hanging fruit method of like, well, this is the only wall space. It's 15 feet up and it's facing, but that's the only wall space we got. So let's put some speakers there. Now, what should have been done, the right design, was actually a soundbar. Now, I don't mean a LG or a Samsung soundbar. That would have not performed well in this room. What I mean is there are professional, high-end, well-designed soundbars with high output from companies like James Loudspeakers or Anthony Gramani, who I work with, has it's not an LCR style one, but it is like a center-only one. And who knows, maybe he'll have an LCR version in the future, but he's got a soundbar that's high output, good directivity. There's, let's see, I'll think of this in a second. Who's the other company that we work with on this? Anyway, there's a lot of brands that sell very high-end soundbars. Even Sonos, who I mentioned earlier, actually has some high-end soundbars. These have higher output. The response is decent. It's good enough for something like this. Directivity is better. There are better and worse ones, but the point is these are not powered soundbars with like everything all built in. They're just basically 3 channels of, we'll call it like bookshelf or better speakers that are built into a single unit designed to mount on the wall. Leon, that's what I was trying to think of. So Leon has some really nice looking, actually that probably would have been the best solution for this room. They make a model that's large and it has enough output that it would work well in this space, but then also they can do like custom finishes and frames for the TV. So the whole thing could have matched the decor of the room, which was very, very high end, high style. And this would have gone well. And it won't shock me if that's actually the fix they go with. There's not a lot of other companies that offer something quite like that with that much output, that degree of quality, but also that nice finish to it. So this could have been done that way. That would have given them the left, center, and right speakers in front of them. And then the surrounds that they did on the sides would have been fine for surround duty. For bass, this is actually a scenario where like there's a couple things that could have been done. One option for bass would have been in-wall subwoofers. So they could have put in-wall subwoofers up there using like a retrofit style design. They actually had to rip the walls up at some point, so they could have probably even done a non-retrofit, which tend to be better quality then, and then redone the drywall. But at this point, you could actually use those front, left, right speaker locations for subwoofers instead and hidden it, and you could have had a lot more bass in the room than you would have had otherwise. So that's an option that they could have done. But even if they didn't want to do that, there are other higher output, attractive subwoofers that could have gone in the room somewhere if they had to. They really, I think, just didn't think through. There's always what I call problem solver products on the market that help to deal with these kinds of issues. The things that they needed to think about were that there's red lines in a design, things you don't do. You can't cross that red line or it's too much of a performance sacrifice. So one of them is the left, center, and right speakers have to be facing you. That is really critical. And the aperture needs to fall roughly within 90 degrees. That's my limit. You should never have a scenario where the aperture between the left and the right speaker exceeds 90 degrees. If it does, you're going to start to have issues. So in this case, it way exceeded 90 degrees and it way exceeded the amount of facing you, if you will. So really rolled off highs, really colored sound. Then there's the output. A 30,000 cubic foot room is a huge room, and it doesn't matter that this was an open space where you're sitting much closer to the speakers than the room's volume would suggest. That volume of room is going to cause a very high reverberant, reflected to direct sound ratio. A lot of reverberation. So you need to make sure that you're using speakers with sufficient output to potentially overcome that, because it's just going to be a loud, noisy room generally, and that's the best way to deal with that. So cheap speakers just don't apply. You got a room that big, you're going to have to step up to big boy speakers, basically. And they make on-wall and in-wall speakers that are big boy speakers that will do the job needed. So those were red lines that shouldn't have been crossed. For the subwoofer, it's kind of the same thing. They should have understood that that subwoofer was not adequate for that room. It's designed to have, I think its maximum SPL is like 105 dB. In a small room, that's fine. Probably with some room gain, you would have gotten about 9 decibels of, maybe not that high, at least 6 decibels of room gain probably would have been likely in a small room. And that would have been pretty good for like a modest system. 2 of those definitely would have gotten somebody some good output in a small, modest system. And that room, you're probably losing 9 decibels from what you get as max output in the way that they measured it, because of how far back from the sub you're sitting and how little reinforcement from the room you're getting. So now all of a sudden this thing is like lucky to be doing 90 decibels basically. It's just a totally inadequate subwoofer for that room. So you got to be doing the right equipment for the space, looking for problem-solving solutions, but understanding the physics of sound here. Like, what is the sound doing in this space, so that if I do these things, I'm either working with or overcoming those problems. And instead what they did was designed a system that worked with the problems to make it worse. Like, everything that was done just made the problem worse than what it could have been. So that's my horror story. I'm actually maybe going to do more of these in the future if I can come up with good examples. But I want to be really crystal clear that I'm not trying to put particular integrators on blast here and say don't use them. I think that these issues come up a lot, and it really is just one of those things where as we start to try to educate the industry and the consumer more, hopefully we see less and less of this over time. So I hope you liked the video. I hope this was informative. Please subscribe to my channel and you'll get more of these. Thanks.